Hi, this is Andy, and welcome to another edition of Math Solutions Online. In calculus, we are interested in the values of a function f of x when x gets really close to some number a, but not necessarily equal to a. Symbolically, we write this as the limit of f of x as x approaches a equals L. But what does this mean? Graphically, we could depict a random function f of x on an xy coordinate plane. On the x-axis, we imagine a number a, which, when plugged into our random function f of x, gives us f of a equals L. Notice the hole at the point x equals a, y equals L, indicating this point is somehow undefined. Now suppose delta 1 is some distance close to a on the x-axis. When you plug that delta 1 value into f of x, you get some value epsilon 1, which is a certain distance from L on the y-axis. Similarly, you could plug in delta 2 to the right of a, but the same distance from a, on the x-axis. When you plug that delta 2 value into f of x, you get some value epsilon 2, which is also a certain distance from L, on the y-axis. You might be able to see that for any random distance epsilon surrounding L on the y-axis, you can find a corresponding distance delta surrounding a on the x-axis, such that if some x values fit between the delta distance, then some corresponding y values will fit between the epsilon distances, even if x never actually equals a. This observed situation is just a very, very precise way of saying that as x approaches a, then our f of x will approach L. Unfortunately, my picture doesn't make it easy to see this on the graph of the curve. What if we zoomed in on that hole in the function? Zooming in super close to any function's hole reveals that if the limit exists, the function line will either be sloping upwards like this, sloping downward, or will be horizontal. Again, if it were legal to plug for x equals a into f of x, we would get f of a equals L. So to write the definition of the limit very precisely, we say that for every positive distance epsilon, there is a positive delta, such that if the distance between some x value and a, that's what absolute value means, is less than a distance delta, then the distance between the corresponding f of x equals y and L is guaranteed to be less than epsilon. If you don't like absolute values, you can rewrite them as follows. If our x value is inside the interval between a plus or minus delta, then our corresponding f of x value must be inside the interval between L and epsilon. Let's look at an illustration. Suppose some factory, called X factory, dumps toxic waste into the water supply of a town called Y. If the X factory doesn't get the mixture right, then they would be poisoning the people that live in Y town. To prevent that, X factory uses a gauge that shows the range of mixtures that are good enough to ensure Y town's water is safe to drink. Complex machinery and fluctuations in the X factory system prevent them from ever staying exactly on A itself, but they stay close to it. This close enough gauge reading is called a delta tolerance level. Wanting to monitor the safety of their water, the people of Y town put in their own gauge showing the acceptable range of safe drinking water. Because the people of Y town's lives are at stake, they get to decide the safe distance or safe tolerance level for chemicals in their drinking water. It must be safe enough to drink. So the left and right boundaries surrounding L on Y town's gauge is called the Epsilon Tolerance. So for any Epsilon tolerance the people of Y town choose, there will be a delta tolerance at the X factory, such that if the factory's gauge is within the delta tolerance, then the town's gauge will be within the Epsilon tolerance.